Today's lesson is based on vertical projectile in one dimension. This is grade 12. Let us start. There is a question paper which we'll be focusing on today. But before we look at the question paper, we need to go through the basics. You need to know certain concepts in order for you to be able to attempt questions. So what you need to know is that we have 4 different types of situations which you will be examined. Now the first one is when, let's say, the person or the object projecting the ball or an object is on the ground level. Then this person is projecting a ball and then the ball comes down. We need to focus on certain physical quantities. We need to explain them in detail in order for you to understand. Now what happens? Let us focus on the motion where the object is going up. Suppose this is point A, B, and then we have C. Now when I say we focus only when the object is going up, it means you are only focusing on this section, only this part of the motion. And then normally we consider up as positive, down as negative. It is important for you to consider the direction because you are dealing with vectors here. Now as the ball is going up, we have physical quantities, which the first one is gravitational acceleration. Gravitational acceleration, we know that the magnitude is always 9.8, and then since it's going down, the direction of 9.8 is always downwards, it will be negative. And then as the ball leaves the person's hand, there is initial velocity which will also be, no, it will be positive because the direction of initial velocity is up. Then we said up is positive. And then from point A to B, point A we have initial velocity vi, which will be positive. Point B we have our final velocity. You must know that always at the maximum point velocity is always 0. We have change in time from A to B, and then we also have change in y. Remember, displacement is a vector, so in this case it will be positive. So this is what is important. You must know that vi will be positive, g will be negative. Change in time cannot be positive or negative because it's a scalar quantity. And then we have change in y, which is positive. That is our displacement. We have final velocity, which will always be 0 because we are looking at the maximum point. We are done with the motion when it goes up. Let us focus when it goes down. This section from B to C. From B to C, what is important? You need to know that our VF will change to VI. Remember, VI, it means the starting point, and then our ending point for the downward path, it will be on C, which will be negative because it's going down. We said downwards it's negative. We have change in time. It will be the same as the time it takes from A to B. And then we also have change in y, but in this case the displacement from point B to point C, it will be negative because it's going downwards. And then we also have g, which will always We also have G, which will always be negative. So what you need to know is that G will always be negative. Whether the object is going up or down, G will always be negative. This is scenario number 1. Let us go to scenario number 2. This is scenario number 2. We can see that the path of the object is like this. Now it's similar to the previous scenario. There's no difference, but we need to consider this as A, B, C. Now when it goes up, our VI will be positive, our G will be negative, and then we have change in time from here up to here. We have change in Y, which will be positive. I'm talking about the path going up. Now the path going down from here up to here. Oh no, before we go there, we know that our VF will be 0 as it goes up, and then when it goes down, our VI will be 0, and then our G will be negative. Now what you need to know is that the time it takes from here to here, from A to B, is the same as time it takes from B to the very same level we see here when it goes down. So this change in time is the same, but the moment it passes through this level, we no longer talk about the time as the same quantity. So this is VI, this will be our VF down here. And then same goes to change in Y. Change in Y from here up to here is the same as change in Y from here up to here. Change in Y will be positive. This is the second situation, second scenario. Scenario number 3, it's when the person is on top of a building or a cliff, and then it's dropping the ball, or it's dropping the object. It's not projecting. The person is not projecting the object, it's actually dropping the object. Now when we look at the situation where the object is dropped, you always need to know that our initial velocity will always be 0 meters per second. Now the reason for this is that the person who's holding the ball before dropping it, his velocity is 0. That is why anything that he is holding will share the very same velocity as the person. So our VF will not be 0, but it will be a positive number. Since we said downwards is positive, it will be negative. We said downwards is negative, and then up it's positive, so it's negative. And then we have G will be negative. We have change in time, we have change in Y, which will also be negative. Let us go to the next scenario. Scenario number 4, it's when we have a person on top of a building projecting. He's not releasing the ball, he's projecting the ball. So our VI will not be 0, but it will be a negative number. Our VF will be negative, change in Y will be negative, G will be negative, and then we have change in time. This ball was not dropped, it was projected. The last one, sometimes this situation most likely to confuse learners. We are looking at a hot air balloon or a moving object. This person is in the moving object. So both this person and the object is moving up. I'm talking about the hot air balloon. And then the person is dropping an object. Now you need to know that the motion of the object will be this direction. It will start by going up and then reaches maximum, it goes down. Why? We need to compare it with the dropping situation. We said the velocity of the ball will be 0 meters per second because the person holding the object is not moving. The velocity of the person is actually 0 also. That is why the object's initial velocity is 0 meters per second. So this means, let's say if the person was moving at a certain velocity, what would be the initial velocity of the ball? It will still take the velocity of the person holding it. So in this case, the person is not stationary. He's actually moving which direction? Up. So the initial velocity of the ball must be in the direction of the person holding the ball. That is why we say the object will start going up and then reaches maximum and go down. Generally, you might think that it will simply go down, but since the person holding the ball is moving upward, so this simply means that the object which the person is holding will also move upward. So once we consider this motion, we can relate it to the second scenario, which we all know that we have VI. VI will be the same as the velocity of the hot air balloon, and then we have VF as our maximum, which will be 0. We have negative G, we have change in time, and then as it goes down, we still can label those physical quantities the same way we did with the second scenario. In order for us to understand this further, we need to attempt questions. We need to look at how to apply this, and then we are good to go. Let us look at the questions. We have November 2016 question paper. We are going to attempt these questions, but we need to analyze. We check what we are given. It's question 3, Physical Sciences paper 1. A ball is dropped from the top of the building 20 meters high. Ignore the effects of air resistance. Now we can see that this situation is that one we talked about as the dropping ball. Now we need to know that our VI will be 0 meters per second. That is the velocity. If we consider up as negative, actually positive, down as negative, it means our G will be negative, our displacement will be negative, our VF will be negative, and then our change in time cannot be negative. This is what we are given. We have the displacement, which is 20 meters. We can look at the questions 3.1. Define the term free fall. The term free fall simply means the motion in which the only force acting is the gravitational force. Then you'll get your 2 marks. You simply write that down, and then you'll get your full 2 marks. Now let us look at 3.2.1. Calculate speed at which the ball hits the ground. We need to know all the equations of motion. Vf is equals to Vi plus a change in time. Vf squared is equals to Vi squared plus 2a change in y. Change in y is equals to Vi change in time plus half a change in time squared is equals to Vf plus Vi over 2 all multiplied by change in time. What is important, you need to take the equations exactly as they are from the formula sheet. So these are the equations we are going to use to answer our questions. Now we need to choose the correct equation to use for this question. We have the change in y. We are given the change in y. We are given Vi. You look at the keywords. The moment they say dropped, you must know that Vi is always 0 meters per second. And if the building or whatever object which this ball is initially in, if it's not moving, then Vi is equals to 0. And then we have G. So basically we have Vi, we have G, we have change in y. So we need to check which equation is suitable for this calculation. So looking at our equations, the first one, do we have Vf? No, we don't. So we cannot use this. Actually, let us look at the question again. Oh, we are actually looking for Vf. So let us look at the equation again. We are looking for Vf. For now, this equation is safe, we can use it. Do we have Vi? Yes, we have Vi. Do we have our acceleration? Yes. Do we have change in time? No. So this equation is out because we have two unknowns. Let us look at the second one. We are looking for Vf. We have Vi. We have G, we have change in time, actually change in displacement. Then this equation is suitable for this question. So we can use it. Vf squared is equals to Vi squared plus 2a change in y. So we have Vf squared is equals to 0 squared plus 2 negative 9.8 multiplied by negative 20. So we square both sides. We are going to have Vf is equals to, take out the square root. So we are going to have square root of 2 negative 9.8 negative 20. This will actually give us 19.80 meters per second. That is the answer of the first question. Our next question, time it takes the ball to reach the ground. So you are looking for this now. We have this, which is 19.80. Now we are looking for change in time. So we can go back to our equations. We have final velocity. We actually have final velocity. We have initial. We have G. We are looking for change in time. Then we can use this equation. So the equation is Vf is equals to Vi plus a change in time. 19.80 is equals to 0 plus, actually this will be negative as it goes down, plus negative 9.8 change in time. Then we know that we have this change in time, so we divide both sides by negative 9.8. Then this will get rid of this. We have change in time is equals to seconds. Our next question, it says sketch a velocity time graph for the motion of the ball. So it's from here up to here, and then it says no values required. There is a lesson video whereby we explain all the graphs, velocity time graph, position time graph, and also acceleration time graph. Just make sure you watch that lesson video. So we have time, we have velocity in meters per second, in this case we don't have any change in direction, so we can just consider this first quadrant. So our graph, it's from 0, it goes this direction. It's actually simple. Just make sure you watch lesson 102 of vertical projectile, also lesson 103, then you'll understand. This is Wahula SJ. Thank you very much.